Strong mathematicians can graph linear functions. Here we have to graph p of x equals 2/3 x plus 1. We know that this is a linear function because the highest exponent of x is 1. Now, how do we graph p of x? Well, if we can find 2 points on the line p of x, then we should be able to find other points on the line. So, let's find 2 points on p of x. To find 2 points on p of x, we are going to arbitrarily assign a value to x and then find the value for p for that value of x. So, I'm going to assign a value to x, and the easiest for me to assign is 0. So I want to find out p of 0. So when x is 0, what is p of x? So that's what we're going to look for. Okay, so p of 0 is equal to 2/3 times 0 plus 1. This is going to give us 2/3 times 0 is 0 plus 1, which gives us 1. So this tells us that when x is 0, y is 1. So let's plot that point. I'm going to go to x equals 0, which is right here. When x is 0, the value of y is 1, so we go up, and that means we have a point here. So we just found 1 point on the line. Now, let's find another point. Well, I could choose to find p of 1. But p of 1, if I assign 1 to x, I'm going to have 2/3 times 1, and that's going to be a fraction. It's not so easy to graph fractions on the grid, so I'm going to choose a number that will give me a whole number when I multiply by 2/3, and that would be x equals 3. Or I could do use x equals 6 or x equals 12. But I'm going to use x equals 3. So I want to find what is p of 3. This is going to be my second point. So p of 3 is 2/3 times 3, and we can put 3 over 1, plus 1, which gives us 2 times 3 is 6, over 3 times 1 is 3, plus 1. And 6 over 3 is 2, plus 1, and we get 3. So we know that p of 3 is equal to 3. All right, so now let's graph this point. When x is 3, y is 3. So I'm going to go to, right now I'm at x equals 0. I go to x equals 1, x equals 2, x equals 3. And then we go up 1, 2, 3. So here's our second point. Now, based on these 2 points, we will be able to find other points on the line. And that is if we get the slope of the line. If you have 2 points on the line, you can determine the slope of the line. And that is if I go from one point to the other and count the vertical distance and the horizontal distance, then I'm going to get the slope. So from x equals 2, from x equals, from this point, which is 0, 1, I go up 2 units and then go to the right 3 units. So again, we go up 2, and then go to the right 3. Now that will allow us to find other points on the line. So now I'm just going to start here at this point and do the same thing. Go up 2 and go to the right 3. I'll end up here. So that means there's another point on the line here. I continue that 1, 2, 1, 2, 3, and here's another point on the line. Now I can reverse directions and to go to the other side. So I can start here, and instead of going up, I could go down 2 and left 3. 1, 2, 3. So now we know that there's another point on the line here. And I could continue if there's more space. 1, 2, 1, 2, 3, maybe right here. So notice, look at these points. These points are lining up. So we can now connect the points to form a line. Let me use, okay, black. Okay, now it's kind of hard to draw a straight line. Let's try. All right, here's the line. All right, there it is. This is the line P of x. Okay. Now, what is the length of the hypotenuse of the right triangle formed by P of x? Here's the line P of x and the two dotted lines. So let's mark that triangle. So the triangle marked by the dotted line, this one, and this other dotted line, and the line PQ. We have this triangle. This triangle is a right triangle. Now we're asked to find the length of the hypotenuse, which is this side here. So let me just erase this now. Okay. So we're going to look for C. We're going to look for the hypotenuse. This is, let me just erase that. This is C. One of the legs is A and the other leg is B. So now we can use Pythagorean theorem to find C. So let's do that. All right, so we'll have here A squared plus B squared equals C squared. Our A is 1, if it starts here, 1, 2, 3, 4, 5, 6. So A is 6. And B is 1, 2, 3, 4, 5, 6, 7, 8, 9. B is 9. Okay, let's double check. So A 1, 2, 3, 4, 5, 6. Okay, and B is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so now that we know exactly what A and B is, we just plug in. So A is 6 squared. Oh, A is just 6. So 6 squared plus 9 squared equals C squared. 6 squared is 36 plus 81 equals C squared. So let's continue here. 36 plus 81 is, okay, 6 plus 1 is 7. 3 plus 8 is 11. So 117 is equal to C squared. Okay, and then we square root both sides. So we'll have here C is equal to, we normally put plus or minus, but we won't do that because we're looking for the length of a segment. And the length of the segment is always positive. So 117, let's break down 117. Well, we know that 117 is not divisible by 2, so we're not going to divide it by 2. Now we're going to try 3. 117 divided by 3. 11 divided by 3 is 3. 3 times 3 is 9. 11 minus 9 is 2. And so we bring down 20. The 7 will have 27 divided by 3 is 9. So 39. So this is 3 times 39. The 39 could be broken down into 3 again. This is 3 times 11, no, 13. 3 times 13 is 39. So therefore, this is going to be 3 times 3 times 13. Therefore, C is equal to, we can cross out the 3's because 3 times 3 is 9. The square root of 9 is 3. And then we'll just bring down the square root of 13. This is the value of C.